Very good afternoon to all. Today we can discuss about the classification of the power amplifiers in subject another electronics, the power amplifiers. What is the major requirement is the power amplifiers are used in the last stage to boost the pure power level of the signal. So this will be required to raise the power level and to deliver a large amount of power and has to have a large current. So in order to achieve this, we have to go for some increase in the base thickness. Before that, if we are increasing the base thickness, this is coming under one of the characteristics. It is can handle large currents. The value of beta should be made high because of this. Once we are increasing the thickness of the base of the transistor compared to a normal transistors, this size of the transistor is made larger in order to dissipate more heat which is produced during transistor operation. So the transformer coupling is used for impedance, achieve impedance matching at the output and the input side. So the collector resistance is also made. So this amplification is done at the last stage in audio applications, and it is going to related to applications related to radio frequencies to employ radio power amplifiers. But this operating point of the transistor plays a very important role in determining the efficiency of the power amplifier. So the main classification is done based on this mode of operation. Another one classification is based on the frequencies. So based on the audio power based on the classification amount of frequencies, there is 20 hertz to 20 kilohertz. It is called as audio power amplifier, and 3 kilohertz to 300 gigahertz. It is considered to be radio power amplifiers. But we are going to discuss only about the classification based on the mode of operation. So based on the portion of the input cycle during which the collector current flows, and the Q point will be varying. So the position of the Q point on the load line decides the class of operation of the power amplifier. We are going to classify based on this as class A, B, class AB, and class C. One more is there. It is coming on under class D. Okay, so first we can see about class A amplifier. See the collector current flow. There is a it is actually plotted between the output characteristics of a BJT. So IC and VCE and the load line is drawn in the characteristics. The Q point lies in the midpoint of the load line. So you will be getting the full cycle of the signal. The power amplifier is known as class A. So full output current flows for the full cycle, 360 degree of the input AC signal. So the Q point lies on the middle point of the load line, and based on the type of the class A amplifier, your efficiency is going to be 25 percentage or 50 percentage. Next is class B amplifier. So when the collector current flows for the full cycle 180 degree of the input, that is half of your input signal, the power amplifier is known as class B amplifier. In this, the Q point is on the x-axis. So you see in the diagram, you have this Q point position to be in the x-axis, that is at the point VCC. Okay, so only the half cycle of the current flows in the output side. So this particular amplifier is having some efficiency higher than class AB amplifier, but it is having some drawbacks also, that is producing the crossover distortions. So next is a class AB amplifier. So in this class AB amplifier, you see the output line, so the full, it is not going to achieve with full cycle. The collector current flows above 180 degree and less than 360 degree. So the Q point lies between the midpoint and the x-axis. It is slightly lesser than the midpoint. It is placed. So because of this, what you will be having is you will be going the achieving the output signal for more than 180 degree but less than 360 degree for a full input cycle. Next is class C amplifier. In this class C amplifier, when the collector current flows for less than half cycle, that is less than 180 degree, then it is considered to be the class C amplifier. But what happens to this class C amplifier is it is having a high crossover distortion. And but the efficiency compared to that, the previous three is it is going to having a high efficiency of 78.5 percentage. So the Q point is shifted below x-axis as per your diagram. The Q point is coming in the negative side. So it is less than the VCC point. You are going to achieve this only during this time. So all these types of class C amplifiers we are going to classify, and the classification based on the operating cycle. It is 360 degree, 180 degree, 180 degree to 360 degree, then less than 180 degree. And the position of Q point for a class A is center of load line. And for B, it is on the x-axis, and for class AB above x-axis but below the center of the load line. And for the class C, it is below x-axis. So efficiency is poor, like 25 to 70%. It is for B, it is 78.5, and for class AB higher than A but less than B, and for class C it is very high. Distortion for class A, no distortion. B, distortion is present. And for AB, distortion is less, but class B, compared to class B, it is having more. And C is the one which is having class very high distortion. But the class C amplifier is the best one, which is used for tuning the frequency in the FM radio. That is the major application of class C amplifier, and is the typical class C power amplifier, which is used in all radio applications. Thank you.